Welcome to Lecture 1.3. In this lecture, I want to introduce the concept of functional groups and introduce some of the simple functional groups that we're going to see, and I would like you to be able to recognize by name in OChem 1. So first off, what is a functional group? Right? Quite the scary word. Essentially, a molecule can be very large, but we can always break it down into the smaller pieces that make it up. Sometimes these pieces matter quite a bit, sometimes they don't, but generally, we want to be able to point to a molecule and discuss it by the groups that it has on it. So for example, if you go to a restaurant, right, and all you're given is a spoon, right, that spoon has a function. It's able to lift up soup, for example, right? But a fork has a different function. We might see a molecule that has a fork and a spoon on it in this hypothetical, right? This molecule could act like a fork, where the functional group that is the fork, but it could also act like the spoon. Generally, I'll talk about these functional groups, help you recognize them, and then provide you some practice material to help solidify the concepts. So to start, we'll look at carbon and oxygen. And with carbon, we only have three functional groups that we really need to know: the alkane, the alkene, and the alkyne. Alk is found in all of these, which generally just means carbon. But what really matters is this letter: ane, ene, and ine. Now, this will map on to a concept known as hybridization. You may have already seen this in intro chemistry, but we will talk about this way more in Series 2 lectures. For now, I want you to recognize that the alkane is the fully single-bonded carbon. We're going to see these everywhere in OChem. So it's not really a very important functional group, but it's good that if I point to a molecule that looks like this, you can tell me that it's an alkane. An alkene, on the other hand, is a double bond, which is carbons that have two bonds shared. These are sp3 hybridized, which again we'll talk about in more detail, and we should know them as alkenes. Lastly, we have alkynes, and these are the carbon triple bonds. So, with that in mind, what might this look like in a bigger molecule? Right? If I asked you to spot the carbon functional groups in this molecule, how would you do it? Well, I'll start with the alkenes and the alkynes. Here we can see two double-bonded carbons. These are my alkene functional groups. I can also see an alkyne, a triple-bonded carbon. Right? Notice that for each of these bonds, there's always two carbons that are involved. Right? These are my alkynes. Then everything else could really be described as an alkane. You typically wouldn't do this, but just be aware that we can talk about carbon molecules this way, right? In my opinion, the real functional groups here that we should care about are the alkenes and the alkynes. That's because they're more reactive. And at the end of the course, once we've learned everything there is to know about carbon, we're then going to look at some reactions that actually use alkenes and alkynes as a starting material to make a bunch of different cool products. So, a few weeks out from that, but if you're excited about that, I'm excited for you. With oxygen, we're going to look at a few different functional groups. Now, we'll cover some of them here and some of them in the next lecture. Here, I want to focus on the oxygens that have two lone pairs. You'll see when we talk about formal charge that this is a type of sp3 hybridized carbon. Two lone pairs and two bonds. But a little too much detail for now. This first example, this squiggly just means that it's connected to something and we don't care about it. I really want to focus on this OH bond. You might recognize that this is a very polar bond, that oxygen is pulling electrons away from the hydrogen. Sometimes we refer to this as a hydrogen bond. In this context, when we see this functional group, I want you to recognize it as the hydroxyl. Now, the hydroxyl is really referring just to that OH. So all of these different functional groups, if we ever see an OH in them, they may contain a hydroxyl. One example of that is the alcohol. The alcohol takes the hydroxyl group and attaches it to what we call an R group in chemistry. If you're worried about the R group, don't worry. This basically just means any carbon thing. So for example, just to spitfire a few out, I could have a methyl group, which is one carbon, attached to my oxygen. I could also have two. or 3. I can add carbons all I want, as long as I follow the rules of chemistry. This whole thing doesn't really matter. It's just a set of carbons. What we care about is the fact that we have an OH, or a hydroxyl group, connected to a carbon. That's what makes this an alcohol. So keep that in mind, that an R group can really mean anything which has carbon. So that's the alcohol. We'll talk a little bit more in detail about the types of alcohol, but one more thing I want to cover is the ether. We can see that in all these different functional groups, our oxygen has 2 single bonds and 2 lone pairs. However, the ether and the alcohol are quite functionally different, and it's important to note that. With the ether, we're connected to 2 R groups. They could either be the same, so for example, here is an example where we have 2 methyl groups or 2 single carbons attached on either side, and we can call this dimethyl ether. We'll talk about the naming of these compounds as well in a future lecture. It's also possible for these 2 things to be different. The thing that makes this an ether is that we have an oxygen connected to 2 different R groups, where with the alcohol, it's important to note that one of those things is a hydrogen. Now, digging into the alcohol, there's actually 3 different types we need to know: primary, secondary, and tertiary. This has to do with how many carbons you have connected to the R group. So here they are. In all cases, our oxygen is only going to be connected to 1 carbon. However, we want to know how many things are connected to that carbon. In our primary alcohol example, we see that there's only 1 other carbon connected, making it a primary alcohol. Here, we have 2 different things connected, making it secondary, and here we have 3. So be aware that we should be able to talk about these oxygen functional groups with that extra detail. We don't just talk about alcohols as alcohols, we talk about them as primary, secondary, or tertiary. To give an example with these, let's look at this example here. So here we see that we have an ether functional group. Right, so I'll circle this and say this is an ether. And I know that because we have an oxygen that's connected to 2 separate carbons. It's good to know that this molecule does contain an ether. Now we can see we have 2 different alcohols, right? They have a hydroxyl group in them, but we'll call them an alcohol because they're connected to carbon. Importantly, this alcohol is secondary, since its carbon is connected to 2 carbons. What do you think this alcohol is? I'll give you a second to think about it. Right? This alcohol is primary, and that's because its carbon is only connected to 1 other carbon. So in terms of discussing the functional groups of this molecule, I could say it has an ether, a secondary alcohol, and a primary alcohol. Breaking down the molecule like this into its individual pieces is very useful later on when we talk about reactions. In general, for now, I want you to know these names, as these names will be very helpful. When they're talked about in your lecture, you'll know exactly what we're talking about. With that in mind, let's move on to lecture 1.4 and talk about a few more complex functional groups that are fair game for OChem 1 material.